All right. Hello, everyone. My name's Sophia. I'm the senior scientist at iSpace. So iSpace is a lunar exploration and transportation company. In today's presentation, I'm just going to give a bit of an overview of our missions, including Mission 1, which launched in 2022, and attempted landing in April 23. And in particular, I'll focus this presentation on our Mission 2, which will be launching at the end of this year, and we'll be carrying on board our very own rover, which was designed, built, manufactured, assembled, and soon to be operated completely in Europe. So I'm really excited and thrilled to be introducing this little guy to you. And in today's presentation, I'll just also talk about some of our additional services that we offer, particularly from our European office, in mission planning and design services that we can offer our customers and clients, the ways in which we collaborate with the scientific community, with increasing accessibility to the academic and research community, to the lunar surface, as well as the arts and general community as well. Disclaimer, so don't trust anything I say. Hopefully. So iSpace is a global company. We have our headquarters in Japan, in Luxembourg, where we have over 40 staff, and continuing to grow, and in the United States as well. So we are a truly global company. We're represented by approximately 30 different nationalities. That number's probably continuing to grow as well. So we're really proud of our employees and the work that we're doing. This image was taken by our Mission 1, Hakuto R, in lunar orbit, a particularly stunning picture, not only because it captures an Earthrise, but if you look closely, there's actually a small shadow on Earth. That's a solar eclipse that was captured as it's passing across Australia. So a pretty stunning picture, that one. So just to give a bit of an overview of our Mission 1, we launched December 11th in 22, had a successful deployment from SpaceX on Falcon 9. Our Series 1 lander is quite small, so to maximize payload, we took a low energy transfer orbit, took us about 4 months to get to the lunar surface, very successful process. We reached lunar orbit in April 23. We're able to gather some data within lunar orbit, capture some data contracts for our customers. And on April 26, we made our attempt at a lunar landing. Now, unfortunately, we weren't successful in our attempt. We did complete our full descent burn correctly. We were upright, reduced our speed to 1 meter per second. Unfortunately, we were just several kilometers above the lunar surface. An error in the way in which the ranging data was ingested into our landing software and the decision-making process that it made resulted in it miscalculating where the lunar surface was. The lander made a valiant effort to attempt a soft landing, but unfortunately not on this attempt. And it was very sad yesterday to see the presentation from Hessa from the MBRC, the LRO image flashing up. So as she said, we are on the moon, just in more pieces than we would have liked. Despite the results of Mission 1, we learnt a lot, and the lunar quest continues. I'll present a bit more on Mission 2, named Resilience, in reflection of our ongoing perseverance. But I'll also talk to you a bit about our Mission 3. So we are part of Team Draper, a NASA CLIPS mission, which we are providing the lander for this mission, landing on the far side of the moon to Schrödinger crater, an incredibly geologically important and exciting crater basin. Really looking forward to the science results of this particular mission. Going on beyond Mission 3, we have funding from the Japanese government for our Series 3, a much larger scale lander, which is currently under design and development, and looking for around a 27-28 launch for that mission. Currently working with customers and partners on developing the payload and the operational planning for this mission. So if you have any technologies, if you have any ideas for mission design scenarios, please come and talk to me. Can put you in touch with the right people. We can work together to design a really cool mission for those future opportunities. So let's talk a little bit about mission 2. So we are using the same series of lander as we did for our mission 1. So further testing our hardware, improving our hardware for this mission. But it's not just a technical feasibility demonstration, it's actually also a commercial feasibility demonstration as well. Notably, our mission 2 does not have any agency payloads on board. We are fully commercial payloads. In the majority, we are payloads for established Earth-based companies that have adapted their technologies to the lunar environment. So we have on board Takasago with a water electrolysis experiment, Euglena with a food production experiment. We also have a radiation probe supplied by the University of Central Taiwan. And an memory disk provided by UNESCO. So UNESCO's goal is the preservation of diversity of linguistics and languages. And on this disk, they have imprinted 275 different languages of their preamble. And we're really proud to be working together to contribute to this goal of the preservation of diversity of cultures and the really emblematic of the global vision for lunar exploration. And last but not least, our little rover. So we have a European payload on board. It's actually an artistic piece. It will have a large unveiling ceremony later in this year, so I can't talk too much about it. What I can say is it's very European. It will be deployed on the lunar surface. We'll be taking some really cool images of it with our rover. And so, yeah, so watch this space. It's a really fun story behind it. And the other key piece of technology on our rover is the scoop at the front. So this was developed by our corporate partner, Epiroc. Epiroc, for those of you who are not familiar, is a Swedish company, a world leader in mining technologies. It was quite an engineering challenge for them for designing. They usually design very large excavation equipment to miniaturize their excavation technology to be suitable for the lunar environment on a micro rover. It's been a really interesting and exciting project for us to work together on. So I just want to take a step back to actually look at the importance of our rover from a European perspective. So our rover was designed and built within our Luxembourg facilities. I actually just left our Luxembourg office, closing the lid on our flight model, sending it off for environmental testing, final environmental testing before it's integrated within our lander. So it's been field tested as well, flight qualified, and will be operated completely from Europe. So we're really excited by this achievement, working closely with suppliers, the academic community within Europe as well. So just to give you a bit of a preview of our rover, this is a demo model. It's not an exact replica of our flight model, but it just shows it in operation within our lunar yard in Luxembourg. So this shows the scoop in operation. Now, due to mass constraints, we don't have any specific, truly scientific analytical equipment on board this particular rover. We will in future models. But we are able to undertake some really exciting experiments, important experiments, using our scoop, using our wheels, using our cameras. And I'd also put out an offer to the group here, if there's anyone who's working on mechanical experiments that would like to work together and collaborate. We're in the process at the moment of testing out various mission scenarios, experiments. Please get in touch. We'd love to hear from you and work together on the development of these activities, particularly if you're planning similar experiments in the future. So it is not just a technology demonstration either. Our scoop will serve a very important function. So iSpace Europe was awarded a contract by NASA to test out the legal framework of transfer of ownership of resources. This is a very small step in that direction, but a very important one if we're talking about the commercial extraction and sale of resources. So we will extract a small quantity of regolith material, and through the legal framework of the Luxembourg Space Resources Law, execute a transaction of a trans well, I can't think of the right word, but we'll be transferring ownership to NASA under this contract. So a really interesting legal problem that we'll be testing out during this mission. So moving on, I want to also talk about some of the other functions that iSpace does. So within iSpace, we aim to be a one-stop shop for mission planning and design. We do this for ourselves. We work in collaboration with our customers, our partners, and also with the helping various technology providers in maturing their design and activities, testing out in various field test and scenarios to really mature their concept design. So yeah, thank you. So involved in that, we do mission planning and design. That's everything from landing site selection through to surface operations planning, field testing and verification, putting instruments on our rover, testing it out in various scenarios. Traverse planning and risk assessment. We have very sophisticated tools for this, not only for planning, but also for operations during the mission as well to make safe decisions. As I've mentioned, mission operations. So we have our lander operations in Japan, our backup, what served as backup operations for our mission 1 in Luxembourg, but will serve as rover operations center for mission 2. And for us at iSpace, we're not just about technology demonstration, just about transportation. We're also about maximizing the amount of scientific return and data return that we can get from our various missions. So data collection analysis is very important to us. And then with that, the final step of data processing analysis, getting the data to the community to understand the lunar environment a bit better. Sorry. So with that, I'll conclude, but very happy to, if you have any ideas for how you would like to work with us, we're very happy to come and approach us. We're very open and look forward to talking with you. Thank you.
Okay, so are there any questions? To the back.
Hi, thank you for the presentation. Francesco Ladini from Italian Space Agency. Just a question regarding the tests that have been performed on the rover. Do you know which kind of regolith was used, and what were you interested in looking for the tests with the rover? And I didn't see it on the video, but was a gravity compensator used for the tests inside the arena or not?
Sorry, I didn't get the last part of that question.
A mechanism to compensate for the difference in gravity for the lunar tests. Thank you.
Yeah. So it depends on what experiment we're doing. So our lunar yard itself is just crushed basalt. So this is more for the operational testing, quick testing of our experiments. We have an outdoor quarry, which we use more for the operators to understand situational awareness, field testing in analog sites, and then we'll also do some small scale testing with simulants as well. So a wide range of potential opportunities. We don't have gravity offloading for this within our facility, but we've done various tests in other facilities for that.